So I guess just as since we have a couple of GitHub questions, just as an exercise, what I'll do is I'll go ahead and I'll create a repository for my code and go ahead and push it up there, and then I can post a link to that repository if you guys ever want to look at the current class version of the programs. Fair enough? Okay, so let's see. So I'll go to my GitHub account. I guess I got to sign in again. And I'll go ahead and create a new repository. We'll call this CSC300 Spring 2015. Good enough. Okay. So we'll call this source code from class. And I'll create this repository. So now that guy is up there and ready to go. All right, so when you first create a repository on GitHub, it kind of gives you this series of instructions. So what I'm going to do is I'm just going to take you through the whole GitHub sequence from the command line. I don't like doing it from Eclipse. For mine seems really sluggish, so whatever. But I'm used to doing it from the command line. So what I'm going to do from the terminal, or if you're on a Windows machine, you would do this from the command line. Although I think that the Git implementation for Windows gives you a Git terminal, right? Yeah. So it's the exact same commands that I'm doing here. It gives you a Unix terminal. So when I first go to my terminal here and I do pwd, this shows you where you're currently sitting. So if I do cd/ like this, on a Windows machine, you'll be at your C drive. On a Unix machine, you're at the root directory. So C drive, root directory, same thing. Synonyms for each other. All right. Now, I'll go into my source directory here for CSC300 Spring 2015. And I'm going to go ahead and right-click on source and go show in System Explorer. And what this does is it just shows me that menu there. All right. Now, if I right-click on that and I say, is it Get Info? Will that give me what I'm interested in? Yeah, this is good enough. So this shows me where this guy is located on my computer. All right. Now, actually, I don't know if I copy that, if that's going to give it to me in a... Yeah, it doesn't give it to me in the right format, but that's fine. So I'll go ahead and walk through this as if you're on a Windows machine, just real quick. Big breakfast. All right, so I need to change into a couple of different directories. So the first thing I need to do is I need to go into the users directory. So cd, let's see, where am I at here? Oh, I'm already in my home directory here. Okay, I'm in users awesome fat already. So I need to go into my Dropbox folder. So now I'm in Dropbox. Then I need to go into the awesome fat folder. Now I'm in there. So if every time I type pwd, that prints out the present working directory. Shows me where I currently am sitting in the directory. Then I need to get into CSC300 2015. Actually, hold on. This isn't right, is it? This is showing an abbreviated thing. Is there a better way for me to get where this guy is located? Maybe this is it. Dropbox awesome fat. Well, I can. I'm just trying to give it to the Windows people. Can't do that. For me, I would just do cd space, drag this guy out there. So this is awesome fat Dropbox, awesome fat. Oh, it was two different directories. CSC300, Spring 2015 source. So this is where that guy lives. So change into your directory so you're sitting in the same place as your source code file. So if I type ls, or on a Windows machine you type in dir, although I think that the Git terminal supports ls on your Windows install. So if you type ls, this gives you a directory listing, and we see my 3 files here. Now, have I actually done a git in here? I have, but we'll just go through the whole process again. So once you're sitting in the same directory as your .java files, you'll say git init, and that will create the Git repository in that directory. So this reinitialized it because it was already there. So that creates that .git folder for you. Okay, once you've done that, we're going to do git add star.java. You can add individual files, but I want to add all the Java files from this directory. So I'll do git add star.java. Now if I say git status, this shows me here's all the files that are currently in that directory, and they've all been modified since the last time I did a commit when I first showed you how to do this stuff, because we wrote some crap last class, right? So these guys have all been modified. So then I'm going to say git commit -m added some of the remove methods, because we haven't finished doing that yet. So the -m allows me to associate a message with this commit. All right. So I'll go ahead and do that. All right. Now, all I've done right there, all that whole set of commands, that just adds stuff and commits stuff to my local repository. Nothing I've done at this point has anything to do with GitHub. This is all local Git. Okay? So I'll bounce back to my GitHub dealy here. And these last 2 commands are the important parts of using GitHub. So I need to add this remote GitHub account, this remote GitHub repository to my local Git repository. So I copy that line, so that's git remote add. You give it a name, so I called it origin, that's kind of the standard. Then HTTPS, the whole line it gives you right here. That's the location of the repository. Okay, so I copy that line, come back out here. I'll elevate this a little bit for you, and I'll go ahead and paste it in there. For those of you who are on the PC, a little trick that if you didn't know you could do this in that Git repository or that Git terminal thing, if you try to paste by hitting Control-V in there, it won't work. But you can right-click and hit paste, and that'll put it in there. So you don't have to type all that crap out. Any of you have some experience typing all that crap out? Or all you Mac users who have done this? All right, so you knew how to do the paste thing? Oh, okay, I got you. This is better.
I deleted all my code doing it through Eclipse, so I agree.
I tried doing the commit. It's giving me an invalid reference. Crap.
Added some old files. Git commit -m. Refs icon. Well, you weren't in the directory with your .java files. Git status, we have notes.java, homework.java, okay. Yeah, that's the problem. You weren't sitting in that directory. I just moved into that directory. You had a directory called homework. So I didn't issue the commit command, but you should be able to press up a couple times and do it now, and it should work. Yay, nay? You're typing a lot of crap for just pushing up. Did it work now? Give it back. I'll just actually do it. Oh, that was you hadn't actually done your Git repository in that directory. You had initialized it in the previous directory.
Okay.
Yeah, so now I'm not even going to trust you to. Boom, boom, boom. All right, we got that. So we have 3 files, right?
Yeah.
So we did git init, git add star.java, got that, git status, got that. Git commit, added some files.
It's still doing it.
Oh, I got the same error. Git add star.java, git commit dash down, added stuff. Okay, that worked. Yeah, I think there was something corrupt with your .get because I just deleted it and recreated it, and now it worked.
Okay.
So, all right. In any case, I like doing it for the command line. That way you, it's consistent no matter what tool you're using. And now you can use Git to do other things. For instance, let's say you have a whole bunch of non-programming type documents you want to share with people. It's an easy way to do it if you know the command line stuff for it. Only time I don't use Git from the command line from a programming perspective is with Xcode, which has a really, really, really good Git tool built into it. You don't have to do any add plugin stuff. It just works. So that's an Apple product, and that works nicely. I haven't actually messed around with the Eclipse one enough, but I really like the command line, and as computer scientists, you should be comfortable with the command line. So it's a good excuse to do that. All right, so in any case, we're doing git remote add. So this is equivalent to what we did a few minutes ago when we added stuff to our repository, right? To our local repository. We added those files. Now I already have, if I do an ls-a, ls-a, notice I already have a .git here. That came from doing the git init. That created a local Git repository. Then I added these .java files to that Git repository. Then I committed those, which added all the changes. Now when I do this remote add, I'm taking my local Git repository and I'm adding it as something called origin, that's the name of the branch, to this remote repository. All right, so it's telling me that origin already exists remotely because I think I already committed it once. So that's fine. So I've added that. Now I'm going to go to that last line over here, which is going to push to that repository. I'm pushing into origin the local master branch. That makes sense? And after you've already authenticated once with GitHub, it usually remembers it, so you won't have to put your username and password in each time. Okay, so now that's done. So if I go back here and I click on this, I should see my files, in theory. And clearly I don't see them. Oh, I pushed it to CSC linked list. Oh, I already had it linked to that. Yeah. So do I need to do... I couldn't add multiple repositories apparently. So those files were just pushed, but they were pushed right here to linked list. So I committed them this long ago. Added some of the remove methods. So can I change? Can I do git remote Okay, I think that worked. So now let me add it to this. Okay, that added it. Now let me do a push to that. So I should now have this one. Yeah, there's the files. So apparently you can only have one remote repository associated with a single local repository. So what I had to do there is to associate it with the new GitHub repository I created, I had to go in and remove the other one I had. So right now, if I do git remote, it shows me the remote repositories I have. So a few minutes ago, when I said remote add, it told me there was already an origin. Actually, maybe I could name it something different. Let's just see if I could have multiple remotes. So I'll go into the linked list thing here. I'll go ahead and grab from the, this is the git directory down there. So I'm going to say git remote add, but instead of this one, I'm going to add it to that linked list one. And I think it tells me there's already an origin. Yeah, remote origin already exists. So let me call this origin 2. Okay, that lets me do it. So now I see that I have 2 remotes. So now I should be able to do a remote push. Origin to master will push it to the new one. Origin 2 of master will push it to the old one. So this is the origin 2 that I just set up. There was no changes, so nothing got committed. But now I can push stuff remotely to origin 2, which is associated with this linked list one, and origin 1, which is associated with my spring 2015. Realistically, you'd probably only have one remote repository, but that's why it was screwing up at first, is I already had an old one in here from the last time I showed you this. So I'll do git remote remove origin 2. So now git remote should only show the origin. All right, so now if I go in here and I make a change, we'll take that semicolon off there. I come back out here. If I do git status, okay, we see I've modified node.java. Okay, so I'll just do a go ahead and I'll say git commit-m made a change to node. Oh, I need to add them first. Git add star.java. That'll add all the changes. Then git commit made change. So this tells me I changed one file and one insertion, one deletion. So it's going to be deleting an old file, inserting a new one for node. then I can do git push origin to master. I don't have to re-add it because I've already added that remote repository. So I'm going to git push origin, which is the local variable name associated with that remote repository, and I'm going to push my local master branch. So that's going to go ahead and push it up there. So now if I go to GitHub, I should see made a change to node right here. And I notice I locally committed it 41 seconds ago. So the timestamp on this is associated when I committed it to my local repository, not when I actually pushed it up. That makes sense? So now I can go back, fix the change I made, hit save, come back out to the terminal. I can do a git status, and I'll see, I've changed the file. So I'll go ahead and just say add star.java. So let's re-add those. It'll only have the one change I made. I'll go ahead and commit that again, made another change. And then I'll push to GitHub 10 seconds ago. Does that make sense? All right, so does that explain what you were having problems with, Alex? Or are you still broken? Still broken? Okay, what's not working? Are you not pressing enter? You want me to take a look at it? I want to make sure everybody can do this stuff. All right, so I'm in the present working directory, so that's in that. All right, so where's your actual, you want these files?
Yeah.
These out here? So I'm gonna go to source. I'm gonna right click, well, for you it's two buttons. You know you can turn on this thing where you can right click with the bottom right hand corner?
Yeah.
Okay, so, but you like to do the 2-1. Okay, so I'm gonna say show in System Explorer, which is gonna give me this directory. I'll go ahead and bring up my terminal. I want to cd into that directory right there. This is where those files live.
Yep.
All right, so now I'm in that directory. So if I type ls, I see all the .java files. Okay, you do have your Git repository in there, so that's fine. So we'll say git status. Those files have been changed, driver and link list. Let's see, git remote. You already have origin up there, so I assume that's the correct repository.
Mm.
Okay, so we'll do git add star.java, and we'll do git commit -m, made some changes, and then we'll do git remote push origin master. Took the command wrong. Let's git push. I don't have to do git remote. Just git push -u origin master. Okay, so now it's up on GitHub.
This should be
39 seconds ago. These two were changed.
Okay.
That make sense?
Thank you.
So it looks like your problem is you need to make sure you get into the same directories where your .java files are. All right? And that goes for all of you. That's a common mistake I've seen students making lately. Before you do any of this commit crap or adding things or initializing the Git repository, you have to make sure that when you type in ls to look at the directory listing, you see the files that you want to add to GitHub. They need to be sitting right there in front of you, these guys right here. All right? If you're sitting way back here in your main directory, you type in ls, there's a lot more crap in there. And if you want to commit all that to GitHub, it's going to take some time. Okay? You're going to be committing your entire directory structure for your computer to GitHub. Not what you want. Make sense? So before you start doing any of these commands, move yourself into the directory where your files exist. On a Mac, the easiest way to do that is right-click on the source directory, because this is where your files live. Right-click on source, say show in System Explorer, and that will show you that directory. Now, you could just do cd space, drag the directory in there. And you know what? I haven't actually tried that in the Git terminal on Mac or on PC. It's possible that will work on there as well. So on a Mac, it's easy. That just changes into the full directory where those files exist. So now I see those files. And at this point, I'm in the place where I need to do all my adding and committing and pushing, all that stuff. Okay? You got to locate yourself in the right spot before you do that. That make sense? Anybody else having issues with theirs? Come on down!
I'm trying it again for.
Are you still sucking? Are you serious? All right, what are you trying to do?
I just want to know what that random icon thing is.
Where's that coming from?
I don't even know.
Are you using the Eclipse plugin?
No. I just dragged it from the source.
What?
The folder. The source folder. I have it saved in Google Drive, so I just...
Well, I'm looking at the source folder. I don't see.
There's no icon file.
Oh, I wonder if it's a Google Drive thing. Let's see. Git status. Yeah, okay. So invalid format refs/icon. Okay. The fix for you, I have to think that that icon thing has something to do with Google Drive. I go in and I typed that command to remove that icon folder. It's going to come back because I removed it before. Okay. So I remove that first, then I initialize the Git repository, then I add the files, and you can commit them.
Okay.
So you got to get rid of that icon thing. It's got to be a Google Drive thing. I know that Microsoft, their cloud thing has some weird stuff to it as well.
OneDrive?
Yeah. So, I don't know. Dropbox won't have that problem, but
Dropbox is
no, I get it. I get
tiny.
it. So,
The free one.
so your fix is that.
Okay.
Your fix is that. All right. No such directory. So where are we sitting? We're sitting there. Okay, so this is your source folder where all this stuff lives.
Yes.
Right there. So we're going to type cd space.
Yep. And then drag it.
Then drag this guy down here. That's going to take me into that directory. So now I'm in that directory. So if I type ls, I see all those files.
Okay.
Okay, so maybe what you weren't doing is you maybe didn't put cd first.
Possibly. I was dragging it from here though too. Would that make a difference?
Quite possibly. I never
Yeah.
tried dragging from there.
Okay.
Yeah, you want to drag this
That
guy.
one? Okay. Instead of the.
Yeah, so once you're there, now you can do, let's see, you don't have your Git in there, but you should be able to type in the instructions now. Do you want me to do it or do you want to try to do it?
Can I see you do it?
Okay.
'Cause
So
that
we'll
will
say
help me.
git init.
Okay.
So that's going to, oh, you don't have the Git installed on here?
Apparently not.
All right, well, we'll install it. Continue on battery power. What version of the Mac OS are you running?
The newest?
Yosemite?
Yeah.
I've never seen a recent Mac that didn't already have Git installed. Do you have Xcode on here?
Probably not.
Oh, that's probably the problem. Git must come with
I have,
Xcode.
Okay.
no pictures, like you just showed me all your pictures. I have no pictures folder myself. I don't know. I just don't save pictures.
I thought about switching over to Eden, but we'll get it working. So had you never gotten this far?
Right.
So I wonder
yeah.
what you were trying to do before. You got the error. Oh yeah. See what that looks like?
Yep.
What you pasted in there?
Okay.
Yeah, that wasn't going to make any sense to it.
Okay.
So that's
So
why
I
you
was
got
just
that. That's why
dragging
you
it
got
from
that error.
there,
Yeah,
so
it
that's
says
fine.
no such file directory because it doesn't know what the heck this is.
Okay. Gotcha.
So now we're in the right place. You have all those files.
Yep. And then
So
we can,
yeah, so we'll be able to
Okay.
do git init, and that once this guy's installed,
yeah.
that's going to create that local .git folder.
Okay.
Then we can do git add star.java, and that'll add all the .java files to it.
Okay.
Then you can do git status, and all status isn't a required thing. That just shows you
What it.
what it sees. It sees,
Okay.
okay, I see these 3 Java files, and here's the changes you've made to them.
Okay.
Then you would do that git remote add like that, and that should be. Are you already in your git thing? So you're just copying these. Do this. You don't need to do that one.
Okay.
You can if you want. It's not going to hurt anything. So then we're doing our initial commit. In fact, actually, this is just the tutorial to add readme.md. I say do add star.java to add all the Java files.
Gotcha.
Then you commit it. So this is just -m says this is my message. So you'll say first commit. Then we'll do our remote add. So this is for CSC300 Spring. So literally just copy this line identically.
Yeah.
Okay, because it already has put in there
What I need.
what you need. And this will create, you only have to do that once. That'll create that local remote repository called origin, kind of like a variable
Right.
locally on your machine.
Okay.
And then from there you can just push. And anything that's, when you type in status, which they don't have there, but if you do get status, anything that's showing up in red on there will automatically get pushed when you push origin to master.
Gotcha.
Let's see, is this guy done cooking? Less than a minute. All right, well, try those commands, but that should work just like that,
Awesome.
now that you're in the right place.
Thank you.
It seems like the Windows one's so much easier.
It's identical.
Well, I mean through Eclipse.
Oh, it's possible that that is easier. I don't use the Eclipse plugin.
Oh yeah, you literally just click commit and push, and then it's there.
Mm-hmm. So once you get the plugin installed, that's fine. I don't know. I like it this way better. But I get it. I mean, like that's why I use the one for Xcode. You know, it's just part of the source. You could just check something out, push it up there. That's actually an interesting reverse side to it. Is you could also use Git to pull a repository down. So if you'll see lots of websites that maybe have some source code available online. They'll give you the Git link, and then you can use Git to pull it down. Or actually, GitHub has a thing where you can just clone on the desktop or download the zip file of it. Instead of using the git command, you can actually just download it as a folder. All right, any other questions about Git? All right, so we all feel reasonably good about it. So let me know if that doesn't work, Katie, after class. But I think it should work. And yours has got to be a Google Drive thing. That's kind of messed up. And it almost sort of makes sense because if you look at the folder for Google Drive, do you see how the folder has like the weird look on it? Your folder, that source folder or whatever, had like the folder didn't look like a normal folder. It had like an imprinted stamp on the actual folder. If you look at it in Finder, that folder looks different. So I'm guessing it's that icon special, I'm not compatible with anything file. That's making that folder look different, but breaking GitHub. So, but it seems to be very happy to put that file back. Seems like because I had already removed it once and it came back. Okay. So we had some homework, right? Homework was to update some stuff in linked list. You were to finish updating removeEnd. Okay, removeAtIndex. Okay, so removeEnd. So if we have nothing in our list, we're going to throw an exception saying you cannot remove the end from an empty list. Fair enough. If the number of elements in our list is 1, we'll go ahead and say remove the front. Might as well call upon the method we've already written. We only have one thing in there. Otherwise, we must have a list with at least 2 things in it, right? So what I'm going to do is I'm going to say node cur node is equal to head for int I is equal to 0, I is less than, I need to accelerate so we can catch up since we spent some time. So I is less than this dot count minus 1, I plus plus. So this is going to move us to the guy who's sitting right before the guy we want to remove. That make sense? So if we have our list, let's see, that's a different class. Oh, this is ours, right? Yeah. So if, oh, hello, that's for my remove front. So go here, here. Ah, there we go. All right, so we set cur here. If I want to remove from the end, which is this guy, I need to get to this guy. So this list currently has what, 1, 2, 3, 4, 5, 6 things in it. So I need to go 5 levels in. 1, 2, 3, 4. So I'm going to bucket 4. Okay, because I'm going less than that minus 1. So if it's got 6, is that what I said? It has 6 of these. Count minus 1 is 5. I'm going less than 5, which is to 4. So this is 0, 1, 2, 3, 4. That's what that for loop does. It makes cur node point to the guy right before the guy at the end of the list. That make sense? Now what I can do is I can set this guy's next node to null. Cur node dot set next node to null. And that's it. We just left this guy out here in the middle of nowhere. He'll get garbage collected. Okay? But we're supposed to return that value, correct? All right, so we can't just disconnect him yet. Before we do that, we need to get, and we're returning an integer. We're returning a payload. Payload to return is going to be equal to cur node dot get next node dot get payload. So we'll go ahead and grab the payload out of that last guy first. Then set cur node's next node to null. Then return payload to return. Okay, so in the picture here, we traversed to here. We took that 3, we copied it into a variable. Payload to return is equal to 3. So we copied it in there. Then we set this guy to null. Then we returned payload to return, which was our 3, which was the value in the last node before we removed it. Make sense? Okay. Let's see. So this is where we throw the exception. That's where we do that. Oh, yeah, it doesn't like it in the for loop. So what we'll do is we're going to say int here. We're just going to do this. Throws new exception. Something went wrong. Let's throw. This should never happen unless we had a poorly structured linked list, right? We know that we're only ever going to return a value inside this for loop. If our linked list is correctly put together, we know as the developers that this for loop's going to do its job, right? We wouldn't be in this else if we didn't first check to make sure it's not the empty list, and we didn't also check to make sure it's not the one list. If we're in this else, it's at least a list that contains two things, which means that this will work.
How are you going to want to take away from count then?
Yes, thank you. So just like we did in remove front, wherever that is it after this? Yep. We decremented count before we return something. The same thing's true here. We want to decrement count before we return, because we did in fact just remove something from our list. So we need to make sure we keep count accurate. Good.
Is it going to do it every time now? It's in the for loop?
It will. It will. Thank you.
So what you're going to do?
We're going to do all this outside of this. We're going to do this. That's going to stay the same. So the job of this for loop is just to traverse this guy to the correct. Wait, no. Hold on. I put all my logic inside the for loop. All this stuff should be after the for loop. Let me do one more undo. All this is after the for loop here, which means we don't need that throw. Inside the for loop, we're going to say cur node is equal to cur node dot get next node. This for loop traverses cur node along our list. That's what this guy does. After this for loop is done, cur node is correctly positioned here in our example. Then we can get the current payload, set the cur node's next node to null, decrement the count because we're removing something, and then return the payload that we just extracted. So somewhere when I was talking, I forgot to actually traverse when I showed you we traversed. So that's what this for loop does. That's the same traversal we've used for everything else.
Do you want it?
No? You don't have faith?
I want to see it.
All right, fine. Fine. All right, so let's get rid of these guys. I'm just going to say throws exception up here so we don't have to worry about that stuff. All right, so let's just see what our list looks like initially. List looks like that. So when I remove end, the last element should be a 3. LL dot remove end, LL dot display. Pointer exception. And okay, well, so this guy has 6 things in it currently. Go back to the code. So not the empty list, not the one list. So we're in the else. We'll set cur node to the beginning. I is going to start off as 0, keep going as long as I is less than this dot count minus 1. So that's going to be less than 5. So cur node is going to, do we have 6 in here? We do. Okay, so first time through, we're going to do this. That's 1, 2, 3, 4. So that's less than 5. 4 less than 5. Oh, we're doing one more jump. So I really need to say less than 2 minus 2. No, that's not the correct way of doing this, though.
Wouldn't it be though? Because you want to be 2 back from the. You technically want to be 2 back from the count.
Well, this is doing it 4 times right now. The problem is I want to say this the very first time.
Well,
so cur is equal to head. That's 1, 2, 3, 4. So the 4th time through is when we'll set it here.
Yeah, so that's count minus 2. Because your count is 6.
Count is 6. but I want to get to bucket 4. Oh, yeah, because it's 0 indexed.
Yes.
Because it's 0 indexed, we need to say count -2. I don't like that. I'd rather start like this.
Yeah.
It means the same thing. I just don't like subtracting 2 from it. Now this should work. What was happening is we were going through that loop one extra time, which was positioning us at the last node. And that's not where we wanted to go. So serves us right for using count. All right. So that's removeEnd. And then the last one is removeAtIndex. The startup disk is almost full. All right, so now removeEnd or removeAtIndex. Int removeAtIndex. This guy's going to take in an int index, and this guy's probably also going to throw an exception. Okay, so to remove an index, what are we going to do? Well, again, if head is null, cannot remove add index from the empty list, regardless of what that index is. Else, if index is less than 0, or index is greater than this dot count. And we said, since we're doing a 0-based index, it should probably be greater than count -1. Because if it's got 5 elements in it, the last thing to remove would be bucket 4, right? You can decide how you want to handle it, whether your linked list is indexed base 0 or base 1. But I think this will be compatible with what ours is.
Would it be easiest just to?
Well, this is for an exception.
Oh, okay.
Yeah, this is an exception that says if they give us a number that's too small or too big to be a real index in our list.
That's the index.
Yeah. I mean, you could choose, because I know we did this in the previous assignment before I showed you exceptions. If you want to let them put in remove at bucket -7 and have that remove front, that's fine. That's fine. But now that we know exceptions, if they say, I want to remove the thinking index -3, we're going to say -3 isn't a legitimate index. Scream at them. Okay, so that's what this else if is for. If you give me something that's too small or too big, I'm going to scream. So we'll throw, here, let me steal this line. Throw a new exception. Cannot remove an index. Index out of bounds. Something like that. And if you want, you can even throw in like a colon and concatenate on what index was to show them that, you typed in a -7. Part of the message is going to be index out of bounds -7. So this is just a string. All right. So else. So if the head is nothing, we're going to remove it. if the index is too small or too big, we're going to throw an exception rather. So head is, if it's empty, we're going to throw an exception. If it's too small or too big, we'll throw an exception. Otherwise, we're in here, so we have something to remove. What are we removing? Well, if index is 0, we can remove front. Correct? And return that value. Else if index is equal to this dot count minus 1, we can return this dot remove end. Else, we're going to be removing somewhere in the middle. Okay? So removing somewhere in the middle, what does that mean we need to do? Well, here's our picture. So let's say we're going to remove this 1 here. So that's bucket 0, 1, 2. We're going to remove bucket 2. So we need to have our count go from here to here. Right, so we're going to go less than index. So if index is 2, we're going to go I is 0, I is less than 2, I plus plus. That's 1, 1 less than 2, yes. So we have the same issue as before since we're doing off count. So I'll start I off at 1 because we're already pointing to the beginning. 1 less than 2, yes. So we'll do 1 jump. 2 less than 2, no. So we're where we want to be. So let's write that loop. So node cur node is equal to head for int I is equal to 1. I is less than this dot count minus 1. I plus plus. Cur node is equal to cur node dot get next node. So that'll traverse cur node to the right place. So now cur node's pointing right here. We want to remove this guy. What does it mean to remove this guy? Well, it means that we need to make this guy point to this guy's next guy, right? But we also need to get the payload from this guy. So let's get the payload first, so we don't lose that. So we'll get payload to return. So we're going to get int payload to return is equal to cur node dot get next node dot get payload. So we've preserved the payload. Now, technically, we could just go ahead and take this guy and connect him to the next node and let the automatic garbage collection deal with this guy. Okay? I like to clean up all loose ends when I'm coding. So I'm going to prefer to go ahead and take this guy and detach that. So that when we're done, we have a node that's just floating out here in space. So it's absolutely 100% clear that this guy's going to get our garbage collected. Okay, even though I'm telling you that as long as nothing's pointing to him, it will get garbage collected. Okay, so that means I'm going to need one extra variable. Because in order for me, I need to remember what this guy, who this guy points to. Okay, I need to be able to get at that because in a second I'm going to be detaching this. And I'll no longer be able to get here. So I'm going to say node temp is equal to cur node dot get next node dot get next node.
Shouldn't you be using this or index minus 1 instead of count minus 1 in your for loop?
Yes. No.
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 Where are you using the index?
No. Hold on.
Yeah.
Yes. Index minus 1, which is based off of count because we wouldn't be in here. Yeah, I'm off today, aren't I? Got a lot of mistakes. All right. Must have had something bad for breakfast. All right, so we wouldn't be in here unless we knew it was a legal index. correct? So we're going to go to index -1, and we use the example of 2. So let's go from 1, 1 less than 2, yes. So let's just make sure we're doing this right. If I said index is 2 that I want to remove, cur starts off at 1. Is 1 less than 2? Yes. So we'll go here. So we don't do -1, just less than index. That'll make us step once. So if we're going to 2, if I starts off at 1, fine. Is 1 less than 2? Yes. Cur equals cur's next node. 1 becomes 2. Is 2 less than 2? No. So we're done where we need to be. All right, so we'll say node temp, and we want temp to point to cur's next node's next node. So what that does is this. I created another variable called temp, and I made him point to cur's next node's next node. Okay, so he points to this guy. Now I can set cur's next node's next node to null. Have it point out to nowhere. So I can say cur node dot get next node dot set next node to null. That's what this does. So this is cur's next node, and I'm going to set his next node. Instead of being where it used to point, now it points to null. So I've disconnected it. Now I can say make cur point to the same place that temp points to. Cur node dot set next node to temp. So that sets it up like this. This guy's just floating out there in nowhere. So he'll be garbage collected because he's no longer connected to anything on either side. But like I said, this was not necessary, the disconnecting it from here. But I like to do it. I like to always make sure we've detached everything. It's one extra line of code, and it doesn't rely on knowledge of how the garbage collection works, because we never know if garbage collection rules will ever change. Make sense? So I like to just make sure I explicitly say what I want. I want this guy to be floating out there in the nether. And even if garbage collection never happens, this guy's not hurting anybody. Okay? No way to get to him, and he doesn't lead anywhere. Finally, we want to return payload to return. And that should be it for removeAtIndex. So we'll come out here. Let's get rid of removeEnd for a second. This will display our list twice, but that's fine. So 0, 1, 2. So let's remove the 5. Dot removeAtIndex 2. And we'll print it again. And we should be missing the 5 now. If we said removeAtIndex 3, we're now missing the 4. removeAtIndex 4. We're now missing the 3. removeAtIndex 5, which is the last legal bucket. We're now missing the 2. removeAtIndex 6 is going to give us an exception. Cannot removeAtIndex index out of bounds 6. removeAtIndex 0. Going to take out the first guy. removeAtIndex 1. Takes out the second guy, bucket 1. removeAtIndex -13. It's going to give us array index out of bounds -13. Make sense? All right, so that is, I would call it a fairly thorough version of removeAtIndex. Could have saved a couple of lines of code here by not doing this temp thing. But if you didn't do the temp thing, I'll take off most of the credit. All right, questions about that? All right. Now, if you had to point to a weakness of our linked list right now, what might you say?
It would be helpful if there was a way to get previous node.
That would certainly be true. Be nice if every node not only knew about its next node, but also knew about the previous node. True statement. Okay. What else?
It's kind of disorganized. There's a lot of methods there. With your syntax.
Well, yeah, there's a lot of methods, but aren't all these methods necessary? I mean, if we want it to look a little cleaner, Eclipse gives you this ability. You can go through and you can just minimize all your methods. Actually, isn't there a way to? I think I can do a collapse. Source collapse all maybe. Well, apparently not. So you can just go through each one and minimize it. Look, doesn't look bad at all now. Okay. Now the reality is for those of you who've ever worked or seen some older languages that have header files, one of the advantages I always point to for header files, like for instance, if I open up Xcode, I have a project in here that I think is Objective-C. So we see all these source code files. Now you maybe start appreciating, like linked list has 3 files. I would call this a fairly simple app. And it has all these source code files over here. But as an example, here's this file called loginvc.m. This would be like one of our Java files. So this is where a bunch of source code is, right? A bunch of crap. Loginvc.h is a header file. It is like a summary of all the crap that's in that one. I know I have these 2 fields, the username text field and the password text field, and I know I have these 2 methods, anonymous button pressed and Facebook button pressed. All right, so this stuff right here is the shorthand version of everything I have here, which is roughly equivalent to me minimizing all those methods like I did. Okay, because if we look at Eclipse right now, that's essentially what we're looking at. We see the 2 fields that we have, and here's all the methods that we have available to us. If we need to fix up one of these methods, we can go in, expand it, and go and fix that method. And then once we have it working the way we want, we can collapse it to make our code a little easier to work through. Make sense? Okay. What if I said I wanted a method public void display in reverse? So I have a method that's called display in reverse. Using our current implementation, how would I display this method, this linked list in reverse? Currently, display works like this. If it's the empty list, I print out empty list, so display in reverse is going to work that same way, right? Otherwise, I start at the beginning, walk towards the end. Okay? But now I need to write display in reverse using the current implementation of my list. Remember, I started this conversation about what limitations does our linked list have. Go ahead.
Couldn't we just each of them add it to the beginning of a new, like a temporary one, and then display the temporary one. So create a new list.
Oh, I actually really like that solution. That's really thinking outside the box, probably. What he wants to do is he wants to create a linked list. Temp is equal to a new linked list. And then he wants to go through for int I is equal to 0, I is less than count, I plus plus. This dot count, right? And he wants to say temp dot add front. He's always adding to the front of the list, so he's going to build the list backwards. This dot get. Oh, it's giving us an integer. That's fine. New node. This dot. Oh no. Add front works because add front takes in an int. Correct. Okay, good. This dot get at position I. Then he can just say temp dot display. So he's going to build temp as the backwards version of this linked list. So if down here we have, let's just get rid of this. We have display. In reverse. Run that. Here's the list forwards. Here's the list backwards. That's a star for the day. It's a really good solution given that's a MacGyver solution, right? Like, hey, I have a list. I have some tools associated with my list. Why not just build another one that's backwards? All right. So looking at it that way, this isn't all that big of a limitation, right? Okay, well, let's say we weren't allowed to write it that way. Threw me a curveball there. Okay, but that's really the way a programmer should think. Exactly like that. That's a really, really, really good solution. Okay, so everybody should shake his hand on the way out of class today. That's what you should be aspiring to. All right, so we're not going to do it that way. Right now we have an issue. I can write a for loop for int I is equal to this dot count minus 1. I is greater than or equal to 0. I minus minus. I could start at the end of my list, and each time through I can get the current value, correct? So I can say this dot get. Hello. The payload at position I, and I'm going to say system.out.print that guy concatenated with an arrow, space. And in the end, I'll do system.out.println. That'll kick it down a line. Oh, it looks like I didn't have spaces in my previous one. That's fine. Okay. Look fine? I guess we had a final null, didn't we? So that's it. We had a space on null. Nowhere else but there. All right. That's it backwards. Now, in terms of the number of lines of code we wrote, was this too bad? No. In fact, you might even say it was shorter. Certainly no longer. How inefficient is this? How many times did I traverse my list? If my list has 6 elements in it, I traversed from bucket 0 all the way to bucket 5 the first time. Then from bucket 0 all the way to bucket 4 the second time. From bucket 0 to bucket 3 the third time. 0 to 2, 0 to 1, 0, and then kicked out of it. I literally walked my list to some degree this dot count number of times. The longer your list gets, the more inefficient this gets, right? The output was fine, but the efficiency of this was terrible. Now let's compare that to his efficiency. For his efficiency, we created a new linked list, went through and created a copy of each node. So we created a brand new node, which had a copy of every payload in it, added it to our list in a very specific way. So we, in effect, traversed our list once, because adding to the front is very easy, right? We just change up the head pointer. We don't actually have to walk our list. So adding to the front's pretty easy. So let's just say we, in effect, traversed our entire list one time and wasted some memory, right? Because we had to duplicate every node. Let's just say that's problematic. Significantly less problematic than this. This is horrible, okay? Works fine, computer's got lots of memory, no big deal, okay? But this would not be a great solution. It's a functional solution. So what we want to do is we want to upgrade our linked list such that there is a pointer called tail that points to the end of the list, and each node knows about the previous node. So you need to update all the add methods, all the remove methods, and finally rewrite display in reverse to take advantage of our new, what's called doubly linked list. Make sense? So that is your homework assignment. This guy right here. And what I'm going to do is I'll commit all these changes, and I'll give you a link to my repository. So you have this as a starting point. All right. And I'm just going to copy this comment. Who? Take advantage. Is that right? Woot. All right. So I'll add the. I'll commit this right now, so it's up on GitHub. I will add this to Angel. This is due on Tuesday. So you're going to have to make changes to every one of those methods. Not a lot of changes, but you're going to have to, every single time you're adding a node's next node, you're also going to have to set up its previous node.
Do we need to get rid of any of our code?
I would think probably nothing. I don't want to say nothing, but probably nothing. You're really just adding an additional ability. Every node now needs to know about his previous node. And then you're creating a second thing like head called tail, except tail always points to the end of the list. So we can quickly get to the end instead of having to traverse the whole list to get to the end. So really, you'll end up rewriting some of your other ones, like you will have to remove some code. Or it would behoove you to remove some code, because when you do things like add end and remove end, you can just go right to tail.
Do we need to add anything to our node class file?
Oh yeah. I mean, node is going to have a new thing called previous node. It already has next node, now it's going to have a previous node. Yeah, so actually in the end, you'll probably actually change several of your methods, but they'll all become easier. Because now you can immediately get to the end of the list. Before, whenever you traverse to the end, or whenever you traverse to a certain node and then backed up one, now you can just go to that node and back up one by using his previous node. You don't have to worry about positioning yourself anymore. You can always get to the previous node, always get to the next node.